Hi everyone, and welcome to Educator.com. Here we're starting our first lesson in algebra-based AP Physics. I'm Dan Fullerton, and I'd like to welcome you to the course. To begin with, let's talk about what physics is. We're going to talk about how we recognize the questions of physics. We're going to list several disciplines within the study of physics. And finally, we're at least going to start to define matter, mass, work, and energy, some of the key concepts that are going to play out throughout this entire course. So, what is physics? I like to think of physics as the answer to all of the questions a 2-year-old might ask. What's a 2-year-old say constantly? Why? 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 The dictionary says physics relates to matter, energy, and their interactions. So, questions that might come up: what is matter? What is energy? How do they interact? And most importantly, why do we care? Well, the why questions are really what start to get more interesting when you take it beyond just a dictionary definition. Why is the sky blue? Why does the wind blow? Why does my teacher smell funny? Why do objects fall down instead of up? Why do airplanes fly and why can't I? Why do the stars shine? Or some nights, why do I have to eat my vegetables? Well, to do this, we have to start talking about what the world, the universe, is made up of. We're going to start with matter. Matter is anything that has mass and takes up space, where mass is the amount of stuff making up an object. And we can get into a little bit more detailed definition than that. But for now, we can think of it basically as anything you can touch. Stars, electrons, Neil Diamond, all mass, all matter. Now, there are actually two types of mass. We could talk about inertial mass, and inertial mass is really how hard it is to accelerate an object. Likewise, we could talk about an object's gravitational mass, which refers to how large a gravitational force an object experiences. So inertial mass and gravitational mass, two types of mass. But what's really slick in physics, anytime we've ever measured anything, the inertial mass and the gravitational mass have always been the same. There's no theoretical reason we really understand yet that says why, but it always works out. And man, is that slick for us as we start our study of mechanics coming up here shortly. So let's do a problem here. On the surface of the Earth, a spacecraft has a mass of 2 times 10 to the 4 kilograms. What is the mass of the spacecraft at a distance of 1 Earth radius above Earth's surface? So we know the mass is 2 times 10 to the 4th kilograms. On the surface of the Earth, we want to know what its mass is up in space. Well, mass, the amount of stuff an object is made up of, doesn't change. Doesn't matter where you are, you still have the same mass in the same object. Therefore, our answer must be number 2, the same mass. We've talked about matter, let's talk about energy. Energy is the ability or capacity to do work. But work in physics has a specific definition. Work is the process of moving an object. And we're simplifying these a little bit. We'll get into more depth later. But if we wanted to put those together, we could say that energy really is the ability or capacity to move an object. A baseball coming at your nose has kinetic energy. It has energy of motion. When it hits your nose, it has the ability to move your nose. That's how you know it has energy. On the same token, if we had a bowling ball suspended up above my head, it would have gravitational potential energy. Why? Because it has the ability or the capacity to move an object. If it were released, it would start to speed up. That potential energy would become kinetic energy. It'd move faster and faster until it collided with me, in which case it would move parts of me in what would probably be a very unpleasant experience. In both cases, energy is the ability or capacity to move an object. Now, in the early 20th century, famous physicist Wild Hare Albert Einstein formalized a relationship between mass and energy, and it's become one of the most famous formulas in physics. His relationship says E equals mc squared, where what he's saying is the mass of an object, a key characteristic of matter, is really a measure of its energy. Energy equals mass times the square of the speed of light. That's just a constant. That's just a number, a fudge factor to make the units work out. What we know is that the source of all energy here on Earth is the conversion of mass into energy. They're really two different sides of the same coin. Or you could think of it as mass is a measure of an object's energy, energy is a measure of mass. There's a very, very close relationship there that's going to play out through the world of physics as well. So then, to come back to what is physics, physics is the study of matter and energy and how they interact, which turns out to be everything. Try and think of something that isn't related to matter and/or energy. Baseball? It's all about physics. Matter, energy, even the roar of the crowd, even the Cracker Jacks that you eat in the stands. Well, what do? You eat matter, you swallow it, you digest it. As you do that, chemical reactions occur. Those chemical reactions are transfers of energy. Then that energy allows you to do work later on. Everything is physics. That's an awfully big bullet list of things to do for an introductory course in physics. So we've got to limit ourselves here. What we're going to focus on are some of the fundamentals. We're going to start with mechanics, talking about how objects move, what makes them move, how they move in circles, how things like gravity work, energy and power, momentum, collisions, explosions. Then we'll talk about fluids, fluid dynamics. Get into thermal physics, thermodynamics, heat. We'll talk about electricity and magnetism, circuits. We'll talk about waves, sound, optics, light. And finally, we'll even touch a little bit on a topic known as modern physics, just things like nuclear physics and a couple other small topics that are much more modern, and modern meaning in the last 100 years or so. So, that should get us going in algebra-based AP Physics. What I'd like you to do before we move on is take just a minute or two and write down 3 things you'd like to learn about in physics. Then, if you can, try and think of ways in which matter and energy relate to those topics. Just a couple minutes to start to see how all of these things play into our study of physics and the universe. Thanks for watching Educator.com. Make it a great day.